Welcome to the Explainer. Hey, have you ever found yourself staring at a folder, looking at a file named something like code underscore v3 underscore final underscore final underscore I swear.js? Yeah, we've all been there. Well, you're in exactly the right place. Today, we're going to demystify Git, the single most important tool that takes all of that chaos and turns it into a calm, predictable, and powerful rhythm. All right, so here's the plan. First, we're going to feel the pain, the chaos that existed before tools like Git. Then we'll dive into the fundamental Git rhythm, the core workflow you'll use every single day. After that, we'll talk about curating your project's history, kind of like a museum curator for your code. Then we're going to pop the hood and see how Git actually thinks. And finally, we'll see how all these pieces come together to build the foundation for amazing collaboration. So, before we can really appreciate the solution, we have to understand the problem it solves. And trust me, it's a problem that every single person who's ever written code or even a Word document has felt deep in their soul. I mean, look at this. This image is practically a rite of passage, right? You're staring at a folder, your heart's pounding just a little, and you're trying to figure out which final version is the actual final version. It's a total nightmare. You have no idea which file has the latest bug fix, and you are terrified of deleting the one that actually works. Now take that personal chaos and multiply it. Imagine a team of 5 people, or 10, or 100, all trying to work on the same set of files. It is an absolute recipe for disaster. See, real teamwork isn't just about people. It's about having a process, a structured way to give and take, to merge everyone's brilliant ideas without overwriting each other's work and losing your minds. And we've all tried the workarounds, haven't we? Naming files with dates, using shared Dropbox folders where files suddenly go missing, or the classic emailing a zip file back and forth. But let's be real. These methods are incredibly fragile. They rely on everyone being perfect all the time, and one wrong move, one accidental overwrite, and hours of someone's hard work can just vanish. Poof. Gone forever. Okay, enough of the chaos. Let's talk about the elegant solution. And the beauty of Git is that it's not some super complicated, rigid system you have to follow. No, at its core, it's a simple, repeatable rhythm, a 3-step dance that, once you learn it, will completely change how you work. So how does Git do this? Well, it organizes your project into 3 distinct areas. And the best way to think about this is like a trip to the grocery store. Your working directory, that's the entire store. It's all the files on your computer that you can see and edit. The staging area, think of this as your shopping cart. You walk through the store and you pick up the specific items, the specific file changes that you want to include in your next purchase. And finally, the repository. That's the checkout. It's where you finalize the transaction, save that shopping cart of changes permanently, and get a receipt, a commit that you can always look back on. So, where do we start? Well, there are 2 main entry points into this Git world. If you're starting a brand new project from scratch, you'll use the command git init right inside your project folder. But if you're joining a project that already exists, you'll use git clone to download a full copy of its history onto your computer. Now listen up, because if you only remember one command from this entire explainer, make it this one: git status. Seriously, this command is your North Star. It's your guide, your map, your best friend. Anytime you feel lost or you're not sure what's going on, just type git status. It will tell you exactly what files you've changed, what's in your staging area, and what to do next. Make it a reflex. And here is that beautiful rhythm in action. First, you modify some files. That's step 1. Then what do? You run git status. It tells you, hey, you got some changes here. So you use git add to move those specific changes into your staging area, your shopping cart. And then you run git status again, just to be sure. It'll now say changes to be committed. Perfect. Now you use git commit to permanently save that snapshot. And when you're done, one last git status tells you your working tree is clean. Modify stage commit. That's the dance. Okay, so you've got the basic workflow down. But just like a good writer edits their work, a good developer curates their project's history. Knowing what to keep out of your history is just as important as knowing what to put in. So let's lay down some ground rules, the big don'ts of Git. First, never commit large binary files, things like videos, high-res images, or compiled programs. They will bloat your repository and make it painfully slow for everyone. Second, and this is a big one, never ever commit secrets. No API keys, no passwords, nothing. It's a massive security risk. Also, keep temporary clutter out, things like log files or compiled code. And finally, a rule for later, don't rewrite history once you've shared it. It can cause major problems for your teammates. So you're probably wondering, how do I stop myself from accidentally committing all that stuff? Well, Git gives you an automated gatekeeper. It's a simple text file called .gitignore. You literally just make a list in this file of all the files and folders you want Git to pretend don't even exist. It's your primary line of defense for keeping your project history clean and secure. Now, a quick word on commit messages. A great commit message is a love letter to your future self and your teammates. It explains the why behind a change, not just the what. And yeah, modern AI tools are getting pretty good at suggesting these messages for you, which is awesome. But remember, the AI is just an assistant. It's still your responsibility to read it, edit it, and make sure it's clear, accurate, and truly tells the story of your changes. All right, we've covered the daily workflow. Now, let's go a little deeper. We're going to peel back the layers and look under the hood to understand how Git is actually built. This part is the key to unlocking its true power. This is where things get really cool. So here is the single most important idea about Git's internal design. Older systems thought in terms of differences or deltas. They'd store one original file and a list of all the little changes. But Git thinks in snapshots. Every single time you commit, Git takes a picture of your entire project exactly as it was at that moment. This might sound inefficient, but it's what makes Git ridiculously fast, especially for things like branching and merging. So let's break down what's in those snapshots. We're going to go slow here. At the very bottom level, you have an object called a blob. A blob is just the raw content of one of your files. That's it. It's just a chunk of data. It has no idea what the file is named or where it lives in your project. It is pure content. Okay, so if blobs are just raw content, how does Git know about your folder structure? Well, that's where the next object comes in, the tree. A tree object is basically a directory listing. It's a list that says, okay, the file named index.html points to this blob, and the subdirectory named CSS points to this other tree. Trees provide the structure, the skeleton that holds all the blobs together. And finally, we have the king of all objects, the commit. The commit is what ties everything together into a single historical save point. It contains three key things: a pointer to the main tree that represents the entire project snapshot, all the metadata, the author, the date, and that all-important commit message, and crucially, a pointer to its parent commit, the one that came directed before it. And that little pointer to the parent commit is everything, because it creates a chain. Commit 3 points to commit 2, which points to commit 1. This unbroken chain of commits forms your project's history, which is technically called a directed acyclic graph, or DAG. All that means is it's a history that flows in one direction and can't have loops. It's a secure, verifiable record of your project's life. All right, now for what is maybe the most misunderstood, but most powerful concept in all of Git. Let's talk about branches. I want you to listen very carefully. A branch is not a copy of your project. It is not a separate folder of files. A branch is just a simple, lightweight, movable pointer. Think of it like a bookmark in a book or a sticky note. It's just a tiny little label that points to one specific commit. That's it. So what does this mean in practice? It means creating a new branch is almost instantaneous. You're not copying thousands of files, you're just creating a new little pointer. When you make a new commit on that branch, the pointer just moves forward to the new commit. This allows you to create these safe, isolated sandboxes to work on a new feature or fix a bug completely separate from the main line of development without any of the overhead. Okay, wow, we have covered a lot of ground. We've talked about blobs and trees and commits and these tiny little pointers called branches. And you might be sitting there thinking, okay, but why? Why does all this internal stuff actually matter to me? I mean, really, why go through all the trouble of building this incredibly elegant but kind of complex structure of snapshots and objects and pointers? What is the ultimate payoff for understanding all of this? The answer is actually pretty simple. All of this, the snapshots, the DAG, the lightweight pointers, all of it is the necessary groundwork. It's the foundation that was built to support Git's one true killer feature, the one feature that has completely revolutionized how developers work together. So what is that killer feature? You guessed it, it's branching. And in our next explainer, we're going to take everything we learned today and show you how to use branching and merging as the true engine of collaboration. You'll see how to work on multiple things at once, how to contribute to a team without chaos, and how to truly master Git. You are not going to want to miss it.